Okay, and we're on, and we're recording, everybody. So, what, can anybody tell me what an absolute value, raise your hand and tell me, what is it, what is an absolute value? Or like, what's the like definition of an absolute value? Oh,
Value is absolute.
Wow.
True?
Is it something? Oh, never mind. I was thinking
It's like, it's something,
I was thinking like this is from zero.
there we go. This is from zero. Now, what does an absolute value do, like to the number? Like, what's the shorthand way of saying it?
Makes it positive.
Makes it positive, right? Now, does it make positive negative?
No.
No, it makes everything positive, okay? Doesn't matter what the number that you plug in, once you evaluate everything on the inside of an absolute value, it just makes it positive. So our formal math definition is that it's just the distance away from zero. So if I say the absolute value of -5, I'm saying how many units is how many units is -5 away from zero? It's 5 full units away from zero, okay? No, you just need to write down the examples. Yeah, you don't need to write this down right now. You can just write down the examples. But the absolute value of a number just makes everything positive. I always consider the absolute value function the happiest of the math functions because it's always positive. It's just always positive. It's always in a good mood, always positive. Okay, so -5 turns +5, 5 turns +5, right? So what if I asked you this? What could x be equal to? Addie?
-3.
-3 or +3. Right? This equation really has two different solutions. See, this is why this is unique. Every equation that we had this chapter, with the exception of those solving for a variable ones, every equation that we were able to solve had one answer, one solution. Obviously, other than the all the numbers ones as well. One solution. We got x equals a number. Never two things. That's weird, right? But this is a case where we get,
Me?
No.
Oh, I'm sorry. You made my heart sink for a second.
Not float. Same.
All right. Now, so x equals -3 or +3. I have two different solutions that this could be. +3 or -3. Okay? This is the first case where we have an equation that you could solve and it gets you two different things. Why is that the case? Well, because again, you're thinking about what number could give me 3 units away from zero. There's two places on the number line that are 3 units away from zero. I could choose this point, or I could choose this point. Each one of them are 3 units away from zero. That's why there are two different solutions here. Why is there a rock in my room? I just stepped on a rock. Like not.
I have it. I'm gonna keep it.
No, I'm gonna keep it.
Frame it.
Is it like a driveway rock?
Yeah, it's like a gravel rock.
Yeah, you can.
Yeah.
Oh.
Three questions.
Good.
Who do that?
I know it's pretty good. It's somebody in the mentoring class. All right. So my question here is, what are the solutions to this equation? Brent.
4 and -4.
Good. I'm going to use the word or, and I'm going to say x could be 4 or x could be -4. Those are my answers. X could be 4 or x could be -4. Yes, I could have two different answers to this problem. That will happen in the future as well. Like once we get to a whole quadratics chapter, a lot of those quadratics will have two different solutions. Yes, there will be two blanks that you write your answer on. Okay? All right. So What are my solutions here then? DJ.
X equals 7 or x equals -7.
Good. Okay, so that's pretty simple, right? When I just give you the absolute value of x equals a number, that's either the positive or the negative version of that number. Sweet, perfect. Give me a million like that on that mistake test, right? Well, it's not that easy. Go ahead and write this one down. Now, we're gonna investigate a little bit here. Okay, we're gonna kind of play around with this and see what the solutions could be. So you may want to hold off on solving this right now. What do we think the solution could be? Okay, 4. I like 4. Okay, so Dane thinks we could have 4. Okay, what would the other solution be? Maybe -4? Because that was like it. So let's check -4. Because that's what the solutions were on the last slide. So let's check -4. Now, how would I check -4? You plug it in, right? Okay, so let's check and see if -4 is a solution. -4 plus 9 is. Uh-oh. Is this a true statement? No. So -4 is not a solution. Let's check 4. Let's just be very clear. Let's check 4. 4 plus 9, is that 13? Yes, that does check out. Okay, so 4 is a good answer, but -4 is not a good answer. So how do we solve this thing then, right? It's not good to just like trust the guess and check method. How do we solve this thing then? Well, let me ask you this. If I hid this inside the absolute value, what 2 values could I plug into that?
+3 or 10 + 3.
No. What 2 numbers could go into this? What 2 numbers? Dane? Right. Whatever's underneath here could be equal to 13 or could be equal to -13, right? Whatever I put here could be equal to 13 or could be equal to -13. Guys, we just created 2 solutions right there. We just created 2 different equations. We could say that x plus 9 is equal to 13 or x plus 9 is -13. And that's how we solve these problems. Go ahead and write that down. Each of these absolute values are going to create, and I should say most of these absolute values are going to create 2 different equations. And you solve them both to get both of your answers. Obviously, the first one, I subtract 9, and that's where my 4 comes from. Use the word or. We subtract 9 for the other one, and its x is -22. And that's my other solution. X equals 4 or x equals -22. Don't trust me? Plug it back in. -22 plus 9. Okay, -22 plus 9 is a -13. What happens with the absolute value? Turns it +13. So -22 is a viable solution. So x equals 4 or x equals -22. You will not get the same value, positive and negative, all the time. That was just special because it was just one, just x equals. Okay. So why don't you guys try that one on your own then? Set it up the exact same way. Absolute value equals positive or negative version of that. Okay, so my 2 equations should look like this. x minus 7 is equal to 6, or x minus 7 is equal to negative 6. Right? The absolute value should equal the positive or the negative of the other side. Because again, think about it this way. If I hid this, I could have either 6 or negative 6 as what goes into here. Okay, so let's solve again. We add 7. 6 plus 7 is 13. We add 7. X is 1. So those are my two solutions. X equals 13 or x equals 1. Don't trust me? Plug it back in. 13 minus 7 is 6. 1 minus 7 is negative 6. And then the absolute value would turn to positive 6. Yeah.
Is that for us?
No. That's right. Obviously. Is that the other thing? Oh, no, there's one. Okay, do that one now. Okay. So we've got 22 or negative 22 is my solution, right? So now I solve that. I add 4 to both sides. In this one, I get 2x is equal to 26. And I divide by 2, x equals 13. In the other one, I add 4 to both sides. And this one, I get 2x is equal to negative 18. And when I divide by 2, x equals negative 9. Those are my two solutions there. Questions about that? Okay. So that's when I have just the absolute value on the left side. But what if I add things to the left side, or subtract, or multiply, or divide? Well, you have to isolate the absolute value before you make your two equations. You have to isolate the absolute value before you make your two equations. You can't start solving until you simplify the equation. Here's what I mean by that. What isolates the absolute value here? What gets the absolute value alone? Ready?
Plus 4.
Well, it already is plus 4.
Minus 4.
Minus 4. I'm going to subtract 4 to both sides. Again, the tendency is to try to say x minus 1 plus 4 equals 7. X minus 1 plus 4 equals negative 7. No. You can't start right off the bat by making your two equations. You have to get it isolated and then make your two equations. Here's what I mean. Absolute value of x minus 1 is equal to 3. And at this point, now we can start to make our two equations. Now we can say x minus 1 equals 3. Or x minus 1 equals negative 3. I add the 1, and I really add the 1 everywhere, right? Keep going plus 1s. X is equal to 4, or x is equal to negative 2. Don't believe me? Check your answer. 4 minus 1 is positive 3. Positive 3 stays positive. Plus 4 is 7. Negative 2 minus 1 turns negative 3, turns positive 3, plus 4 is 7. They both check out. They both give me the solution. They both give me 7.
Is he getting home or away tonight?
Away. Now,
They're against 2.
can I distribute in to an absolute value?
Yeah.
No.
No, you cannot. So instead of distributing in, what can I do? Instead of working with the multiplication coming in, how do I get rid of the multiplication? Eddie? I heard it back there. What was that?
Divide.
Divide. I divide by 3. Instead of distributing, because we can't distribute into an absolute value. It's one of those ones that we can't break into. We divide both sides by 3. We isolate the absolute value. Get the absolute value alone before you make your 2 equations. And at this point, that's when you make your 2 equations. Don't start doing it ahead of time. You can't say 12 and negative 12. Nope, you got to wait till it's 4. You got to wait till the absolute value is completely alone. So x plus 2 is equal to 4, or x plus 2 is equal to negative 4. We subtract 2, so we get x is equal to 2, or negative 6. Don't believe me? Check the answer. 3 times 4 would get us 12. Plug in the negative 6. Negative 4 would turn positive 4. Times 3 is 12. It does check out. Questions about that? Now, everybody write down this next one. This is a tricky one, because this is very similar to those solving for a variable ones. Those solving for a variable ones. Okay, what's being done to the absolute value? What operations are being done to the absolute value? Brennan?
Multiplication and subtraction.
Right, so what should come first? Addition, not division. Addition. I know, I'm just saying, I'm just emphasizing it. Not division, addition. I've got to get rid of the addition and subtraction first. Then I can divide. So I plus 6 to both sides to get a 2 absolute value of x minus 3, bring down everything that we didn't use, and then 6 plus 4 is 10. Now we divide. So the absolute value of x minus 3 is 5. And it's at this point again, now that the absolute value is completely alone, that's when we start to make our 2 equations. We gotta
add those lines.
Yeah, you got to keep them there. I didn't add that in. You got to keep them there until the very end.
They confuse me.
It's okay. Don't worry about it. You got to wait till the end, and then you say x minus 3 is 5, or x minus 3 is negative 5. So we add 3 everywhere. We get x is equal to 8. X is negative 2.
You're almost done. You said 1 page and I almost have 1 page.
Really? I'm sorry. Yeah, we just have 2 more examples to do.
Nice, man.
All right. Questions about that? That's pretty much as difficult as it could get for this type of problem. I want to show you this though. Not all absolute value equations have 2 solutions. Okay, so I am insinuating here that something weird is going to happen with this one. Okay, let's try to solve it like we would any other one then. Let's try to solve it like we would any other one. What would I do to solve this one? Okay. Good, subtract 8, very good. Subtract 8, so that means I get a negative 3 is equal to the absolute value of x plus 2. Now, from here, once the absolute value is completely isolated, I would break it apart into 2 separate solutions, right? Negative 3 is equal to x plus 2, or positive 3 is equal to x plus 2, right? We subtract 2. Okay, what's weird about this? I'm not seeing anything weird going on. Why? What's happening here? Now, again, I was insinuating, I got 2 solutions, but I was insinuating that it may not have 2 solutions. But I got 2 solutions. So, but maybe one's not right. Maybe one's not, maybe I screwed something up. How would I check to see if I screwed something up? Plug it in. Okay, so let's try the negative 5. Let's try the negative 5, because maybe that's not right. I don't know. I don't know. 5 is equal to the absolute value of negative 5 plus 2 plus 8. Right? I just plugged in negative 5. Okay, 5 is equal to the absolute value of -3 plus 8. What is the absolute value of -3?
Three.
+3. Oh. Is -5 a solution?
No.
What about 1? Let's test 1. 5 is equal to the absolute value of 1 plus 2 plus 8. Ooh. Again, what's the absolute value of +3?
-3.
No,
Oh,
it doesn't.
3.
Turn it back. It's +3. So it stays positive. 3 plus 8 is 11 again. So is 1 a solution? Okay. So what did I screw up? Where did I go wrong? Maybe my question is, what is a solution?
Maybe
There's no
Maybe there are no solutions, and that's the case. There are no solutions here. Why? Why?
Nothing equals.
Somebody catch it. I know somebody got it last period.
There's no solution.
Why? What'd you say?
No number works.
Ah, she found it. It's right here. Can an absolute value ever equal out something negative?
No.
Can I ever get out a negative? No. So I could have stopped right here. I didn't need to do any of that. If you catch it right here, the absolute value is equal to a negative, boom, done. Stop in your tracks, no solution. Okay? You can never equal a negative with an absolute value. Okay, so I could have gone right here. Now, obviously, we did all that work, so I'll just keep it shown there, but you could have stopped right here, this -3, right here, for the folks playing along at home. Right. Oh. It's magic. Smart board magic.
Wait, are you still recording for that one?
Yeah, I'm still recording.
What's there?
Yeah, they can hear you.
Wait, do we have people in our class that are in online?
I mean, like, it's for like,
Oh, anyone.
anybody that's not here today.
Give me my food back. Only give me my food
Give,
She had a donut.
give the food back. Give it back.
She gave it to me and
I did
then
not.
went
I
back.
was talking to you.
Then she gave, yeah. See, even.
Okay.
Oh,
Shh. We'll make this one the last example here.
yeah.
Okay, what would I do to get the absolute value alone? I would add 6 to both sides, right? I see a -6 plus, right? So I'm gonna add 6 to both sides. Now what happens here?
They cancel out.
So I'm gonna get absolute value of x minus 4 is equal to 0. Does this mean a no solutions? No, that's not what that means. This means that this is gonna equal 0. So I would go here and say, okay, the absolute value is the positive or negative, right? Positive 0, does that make sense? Negative, does that make sense? What would be a negative times 0? What's anything times 0?
0.
So that negative really doesn't make sense there, right? Didn't I write down the exact same thing?
Yeah.
So I don't really need to write down the other one. Instead of 2 solutions, this only gets 1 solution. X equals 4. So sometimes you will get 1 solution. Sometimes you will get 2 solutions. Sometimes you don't get any solutions at all. Okay? It all kind of depends on how the problem worked out in the end. All right. I'm going to stop recording. Everybody say bye.
Bye.